Download this code from codegive.com, link in the description below. OK, let's delve into Couchbase at LinkedIn, as it was presented at Couchconf SF 2012. I'll aim for a comprehensive tutorial covering the key concepts, some potential uses at a company like LinkedIn, and code examples, keeping in mind that the specific internal LinkedIn architecture is obviously proprietary, so we'll infer likely scenarios and implementations based on the publicly available information and Couchbase capabilities at the time. Context: Couchconf SF 2012 and Couchbase's position. In 2012, Couchbase was still a relatively young but rapidly growing NoSQL database. It was positioned as a key-value store with added document-oriented database features. The presentations and discussions at Couchconf at the time generally emphasized high availability and scalability. Couchbase's ability to handle large volumes of data and traffic with built-in redundancy and horizontal scaling was a major selling point. memcached compatibility. Its compatibility with the memcached protocol allowed for a smooth transition for applications already using memcached for caching, offering persistence with minimal code changes. Document-oriented capabilities. Supporting JSON documents and eventually a query language, nosql, which came later. Couchbase aimed to provide more flexibility than simple key-value stores. Ecosystem. The growing client libraries and integrations with popular frameworks, Java, .NET, PHP, Python, Node.js, made it easier to adopt. LinkedIn, potential use cases for Couchbase. Given LinkedIn's massive scale and the nature of its data, user profiles, connections, activity streams, job postings, recommendations, groups, etc., Couchbase would have been a strong contender for various use cases. 1. User profile caching. Caching user profiles, name, title, summary, skills, experience, for fast retrieval. Frequent reads on profile data make it an ideal candidate. 2. Social graph data. Storing and querying social connections, who is connected to whom. This could involve storing adjacency lists or using more sophisticated graph representations within the documents. 3. Activity feeds, news feeds. Storing and retrieving user activity, posts, shares, likes, comments. Couchbase's performance could be crucial for delivering real-time or near real-time feeds. 4. Recommendations. Caching pre-computed recommendations for jobs, connections, skills, or groups. This could involve complex algorithms that are computationally expensive, so caching the results is vital. 5. Session management. Storing user session data, authentication tokens, user preferences, cart information, for logged-in users. Couchbase speed and availability would be crucial. 6. Real-time analytics aggregation. Aggregating and storing real-time metrics, page views, clicks, impressions, for dashboards and reporting. Key Couchbase concepts, circa 2012. Buckets. A logical grouping of documents, similar to a database in a relational system. Buckets have configuration settings for memory allocation, replication, and persistence. Documents. The fundamental unit of data storage. Documents are stored as JSON. Keys. A unique identifier for each document within a bucket. Keys are strings. Views, MapReduce, a way to query and aggregate data within a bucket. Views are defined using JavaScript map and reduce functions. N1QL SQL-like querying came later. Clusters. A group of Couchbase server instances that work together to provide high availability and scalability. Asterisk replication. Asterisk data is automatically replicated across nodes in the cluster to ensure availability in case of node failures. Asterisk auto failover. Asterisk if a node fails, the cluster automatically redistributes its data and continues to operate. Asterisk memcached protocol. Asterisk Couchbase is compatible with the memcached protocol, allowing you to use memcached clients to access data. Asterisk client libraries. Asterisk client libraries are available for various programming languages, including Java, .NET, PHP, Python, and Node.js. Code examples: conceptual, Java using the Couchbase Java SDK, pre-N1QL. Here's a conceptual example of how Couchbase might be used in a Java application at LinkedIn. This focuses on storing and retrieving user profiles. Remember, the specifics of LinkedIn's internal implementation would be different. Explanation asterisk. 1. Connect to Couchbase asterisk. The code connects to a Couchbase cluster using Couchbase client. You'll need to replace the URI with the address of your Couchbase server. The bucket name and password are also specified, if your bucket has authentication enabled. 2. Store a user profile asterisk. Asterisk a JSON object is created to represent the user profile data. In a real application, you'd likely use a Java object and a JSON library like json or json to serialize/deserialize it. Asterisk the client.set method stores the JSON string in Couchbase with the user ID as the key. The 0 for the expiry means the document will not expire. 3. Retrieve a user profile asterisk. Asterisk the client.get method retrieves the profile data using the user ID. Asterisk the retrieved data is cast to a string and then parsed into a JSON object. 4. Incrementing a counter asterisk. Asterisk client.increased is used to atomically increment a counter associated with the user, example profile views. This demonstrates Couchbase's atomic operations, useful for real-time analytics. 5. Shutdown asterisk. The client.shutdown method gracefully closes the connection to the Couchbase cluster. Important considerations: LinkedIn context. Asterisk data modeling asterisk. Designing the data model is critical. For connections, social graph, you might consider using adjacency lists, a document for each user containing a list of their connections. Asterisk indexing asterisk. In 2012, indexing was primarily done using views, MapReduce. For complex queries, views were essential. Asterisk sharding/distribution asterisk. Couchbase automatically shards data across the cluster. However, understanding how data is distributed and ensuring even distribution is important for performance. Asterisk monitoring asterisk. Monitoring Couchbase's performance, CPU usage, memory usage, disk I/O, latency, is essential for identifying and resolving issues. Asterisk security asterisk. Securing access to the Couchbase cluster is vital. This includes setting up authentication, authorization, and potentially encryption. Asterisk cache invalidation asterisk. When user profile data changes, example a user updates their title, you'll need to invalidate the cached data to ensure that the application displays the latest information. This could involve deleting the cached document or updating it with the new data. Moving beyond 2012, N1QL and modern Couchbase. The Couchbase landscape has evolved significantly since 2012. The introduction of N1QL, SQL for JSON, greatly simplified querying and made Couchbase more accessible to developers familiar with SQL. Later versions also introduced improved indexing techniques, global secondary indexes, GSIs, that made query performance even faster. Modern code example: conceptual, Java using the Couchbase Java SDK, with N1QL. Here's a conceptual example showing how N1QL could be used to query user profiles. Note that N1QL arrived after 2012, but this illustrates how things would be done today. Key differences in the modern example: Asterisk cluster and bucket objects. Asterisk the code uses the cluster and bucket objects from the newer Couchbase Java SDK. Asterisk JSON object. Asterisk the code uses JSON object to create JSON documents. Asterisk N1QL query. Asterisk the code executes a N1QL query to retrieve user profiles based on criteria. Asterisk type field. Asterisk the added field, type, helps in selecting the documents. Benefits of N1QL. Asterisk familiar syntax. Asterisk N1QL SQL-like syntax makes it easier for developers to learn and use. Asterisk more powerful queries. Asterisk N1QL supports a wide range of SQL features, including joins, aggregations, and subqueries. Asterisk improved performance. Asterisk with proper indexing, GSIs, N1QL queries can be highly performant. Conclusion: Couchbase could have been a valuable asset for LinkedIn in 2012 and remains so today. Its scalability, availability, and document-oriented capabilities make it a good fit for a variety of use cases. While the specific implementation details at LinkedIn would be proprietary, this tutorial provides a solid foundation for understanding how Couchbase could be used to build high-performance applications at scale. Remember to always tailor your data modeling, indexing, and configuration to your specific application requirements and monitor your Couchbase cluster for optimal performance. The introduction of N1QL has greatly enhanced Couchbase's capabilities and made it an even more compelling choice for modern applications.